You look at the news coming out of India lately, and, well, it's pretty stark, isn't it? These relentless heat waves, then boom, devastating flash floods.
Yeah, it really feels like the extremes are hitting more often and harder, too.
Exactly. And it makes you wonder, how is a country like India, so vast and diverse, using, the latest tech to try and get ahead of these climate challenges?
Well, that's exactly what we're digging into today. It's a
Mm.
really critical question.
Right. And we're seeing this big shift, aren't we, towards artificial intelligence, machine learning, trying to basically revolutionize weather forecasting.
Precisely.
Yeah.
Think of this as your quick guide to understanding how India is tackling climate risk with AI, a really significant development.
Definitely. And for this deep dive, our main source is a detailed piece from The Hindu.
hmm
Our plan, our mission, if you like, is to unpack how India is adopting AI for weather prediction. We want to look at the big initiatives, see how it stacks up against the old ways, talk about the hurdles and what solutions are on the table.
Sounds
So maybe start with the basics. What exactly is AI-based weather forecasting in this context?
Okay, so fundamentally, it's about using AI and ML algorithms to crunch just massive amounts of diverse data. We're talking satellite images, sensor readings, historical patterns, everything.
Ah,
And the goal is to get much more accurate predictions, especially for those, really high impact extreme events we were just talking about. It's all about helping people make better decisions, manage disasters more effectively.
right. Proactive decisions. Makes sense. It's not just looking at old data differently. It's using a new kind of, well, intelligence to pull out insights.
Exactly.
Now, the Hindu article mentions some key projects. Let's talk about WENS first, the Weather Information Network and Data System. That sounds big.
Oh, it is. Very ambitious. It's led by the Ministry of Agriculture, and the idea is to generate really local, long-term weather data. Hyperlocal, actually.
And the scale, it mentioned a huge number of ground stations.
Yeah, the plan is, get this, over 200,000 ground stations across the country.
200,000. Wow.
I know, right? Think about that density. A huge network feeding back granular data right down to the village level.
So what difference does that sheer volume actually make? For the forecasts, I mean.
It makes a massive difference. More stations mean a much, much finer picture of what's happening in real time. This hyperlocal data is, well, gold for things like precision agriculture, knowing exactly what a specific farm needs, or for really targeted disaster response.
Right, knowing exactly where the problem is developing.
Precisely. Timely interventions become much more possible.
That hyperlocal angle feels key for India, with all its microclimates and different farming zones. Okay, what about the AI and Machine Learning Center in Pune? Ministry of Earth Sciences runs that one.
Yes, that's right. Their focus is more on boosting the precision and detail of the forecasts themselves.
So specific applications.
They're working hard on short-range rainfall predictions, super important for flood warnings and water management, also developing high-res weather data just for cities.
Ah, urban areas. Good point.
And they're using AI with Doppler radar data for nowcasting, predicting rain and snow in the very near term, like the
Yep.
next few hours.
So if you're in a city, this could mean getting a much better heads up about a sudden downpour.
Exactly that. That kind of granular, almost instant info is invaluable for managing, urban flooding, traffic chaos, even just planning your day.
Makes sense. And then there's the monsoon prediction work at IIT Delhi. That feels like a huge one, given how vital the monsoon is.
Absolutely critical. The monsoon drives so much of the economy, especially agriculture.
And the article mentions some pretty impressive results for their AI models.
Yeah, the DST Center of Excellence there, working with others, they've built these AI models specifically for the Indian monsoon. They feed them tons of historical climate data, plus data on the big climate drivers, like El Nino, the Indian Ocean Dipole.
The big ocean patterns that influence things globally.
Exactly. Those are key factors, and the success rate they mentioned.
Yeah, what was that again?
61.9% success for forecasts between 2002 and 2022. And importantly, the article notes these AI models actually did better than the traditional physical models over that time.
Better than the traditional methods. That's significant.
It really is. Plus, they can predict rainfall patterns months ahead. Think what that means for farmers planting crops or authorities managing water reserves.
Months ahead. Wow.
And the models keep learning. They get updated with new data, so they can potentially get even better over time. It's not just a small step. It feels like a real leap in predicting India's most crucial weather system.
A huge leap, potentially transformative for agriculture. Okay, so all these different efforts, WINES, the Pune Center, IIT Delhi, They seem to fit under a bigger umbrella, right? This Mission Mausam.
Yes, exactly. Mission Mausam, launched in 2024, is the big MOE's initiative to pull it all together and really modernize India's whole weather and climate forecasting system.
And the tagline is weather ready and climate smart.
That's the one. Really captures the goal making India resilient.
So what specific needs is it trying to meet? What are the core challenges it's tackling?
Well, like we said, India's huge reliance on agriculture makes accurate monsoon forecasts essential. Food security depends on it. Add to that the increasing climate weirdness, more extreme events. You absolutely need better, more actionable weather intelligence.
So Mission Mausam is the response to that pressing need.
It is. It aims to improve monsoon prediction for better crop planning, support rural development through smarter resource management, better infrastructure planning. It connects improved forecasting to real-world benefits.
Right. It's not just about the forecast itself, but what you do with it. How is it being implemented? Who's doing the work?
The main players are the IMD, the India Meteorological Department, plus IITM and CMRWF.
Okay.
And the strategy is kind of two-pronged. One, build up the physical infrastructure, more Doppler radars, more weather stations, getting that raw data flowing. Two, use India's supercomputers like Pratyush and Meteor to run these really complex climate models.
Leveraging the hardware. Makes sense. Are we seeing results yet? What's the status?
Yeah, there's definitely progress. The article mentioned over 37 Doppler weather radars are already up and running. That's a big boost to real-time monitoring.
Okay.
And there's the Mausam app provides forecasts for, I think, 450 cities now.
Yeah.
That's a direct outcome people can use.
Yeah.
Plus, the seasonal prediction models under the older National Monsoon Mission have already gotten noticeably better.
Sounds like momentum is building. Now, you mentioned earlier how AI is different from traditional methods. Can we compare them a bit more? AI versus numerical weather prediction, NWP.
Absolutely. It's a good comparison. They're quite different beasts, really.
Yeah.
Let's look at a few things. First, data. AI models are purely data-driven,
Yeah.
meaning they chew through massive data sets, historical, real-time, looking for patterns, correlations. The interesting thing is they don't necessarily need to understand the underlying physics of the atmosphere the way we do. They find hidden links in the data itself.
Okay, whereas traditional NWP is based on physics.
Exactly. NWP uses complex mathematical equations, fluid dynamics, thermodynamics, to simulate how the atmosphere behaves. It tries to model the physical processes.
Did you give an analogy, maybe?
Sure. Think about predicting a cricket ball's path. NWP is like calculating the bowler's force, the spin, air resistance, all the physics. Very detailed.
Right.
AI is more like watching thousands of videos of that bowler, seeing the stance, the release angle, where the ball went each time, and learning the pattern to predict the next one, even without knowing all the precise aerodynamic equations.
I see. Pattern recognition versus physics simulation. What about computing power and speed?
Well, AI can be great for real-time stuff because it learns continuously from new data. It's quick at spotting subtle shifts. NWP, especially for longer forecasts, needs serious supercomputing muscle. Those simulations take a lot of time and power.
So AI might be faster, more adaptable for the short term, and flexibility. Can AI handle different kinds of data?
That's a big plus for AI, yes. You can train AI models to use diverse inputs, maybe ocean salinity, land temperatures, things NWP might not typically use. And you can tailor them for specific regions or weather types. NWP models are a bit more rigid, based on fixed physical rules. Updating them for new data types or extreme events can be complex.
And the crunch question. Predicting those extremes, heat waves, floods, does AI have an edge there?
The signs point that way, yes. The Hindu piece suggests AI often gives more accurate, earlier warnings for extremes, probably because it can pick up on those faint early signals in the vast data that traditional models might miss, especially for really localized, fast-developing events.
It sounds incredibly powerful, but, given India's scale and complexity, there must be challenges, right? What are the big roadblocks to making this work effectively everywhere?
Oh, absolutely. There are significant challenges. Number one is probably data quality and just plain availability.
Garbage in, garbage out.
Pretty much. AI models feast on data, but it needs to be good quality, consistent, comprehensive.
Oh.
Getting that from everywhere in India, especially remote areas, is tough. Sparse or inaccurate data. That directly weakens the AI forecast.
Makes total sense. What else?
Well, weather itself is just inherently chaotic, nonlinear. Predicting it precisely is hard, full stop, even for AI. And India's regional climate variations add another layer of complexity.
Right.
Then there's the black box problem.
But what now?
The black box. Sometimes with AI, it's hard to know why it made a specific prediction. The reasoning isn't transparent, and that can make people, especially non-experts making critical decisions, a bit wary. Trust issues.
I can see that if you don't know how it reached the conclusion. Huh.
Yes.
Are there also skills gaps or infrastructure issues?
Definitely. You need people who really understand both climate science and machine learning. That cross-disciplinary expertise is still quite rare in India. And like we touched on with NWP, running these sophisticated AI models, especially high-resolution ones, needs serious computing power, high-performance GPUs and things. Not every institution has that kind of infrastructure readily available.
Okay, so data issues, complexity, the black box problem, expertise, infrastructure, quite a list. So given all that, how can India actually make AI forecasting more effective? What are the solutions?
Well, one really promising path is a hybrid approach,
Hybrid, meaning
meaning combining the strengths of AI with the strengths of the traditional physics-based models. Use AI's data crunching power to find patterns, but use the NWP's understanding of physical processes to ground it, perhaps refine it. Get the best of both worlds.
fusing data insights with physical laws? That sounds smart.
It could really improve accuracy, especially for complex situations where one method alone struggles.
What about getting more data? The article mentioned crowdsourcing.
Yes, that's a fascinating idea. Using things like Google Maps or specialized AI like Google DeepMind's GenCast, you could potentially have ordinary people contributing localized weather observations through apps.
Like citizen scientists.
Exactly. Imagine getting real-time ground-level reports feeding back into the AI models. That could be incredibly valuable for fine-tuning predictions, especially for those sudden localized storms or floods, maybe integrated into the Mausam app.
Turning millions of phones into mini weather stations. Interesting.
And expanding the official networks, too, presumably.
Absolutely vital. Expanding the networks of automatic weather stations, the AWS and rain gauges through things like winds, aiming for those 200,000 plus new stations that builds the foundation. Maybe even tap into private sector networks if the data can be integrated smoothly.
More data, better data. And collaboration, both inside India and globally.
Crucial. India can definitely learn and accelerate things by working with global leaders, Google, NASA, others, joint projects, sharing data and best practices.
Makes sense? And internally, building that expertise pipeline is key. Setting up dedicated AI and climate science institutes like DST and MOEs are supporting, holding conferences, running training programs. You need a steady stream of skilled people.
Okay, this has been really illuminating. A deep dive into how India is using AI to tackle these huge weather challenges. So just to wrap up the key points for you listening, India is definitely making big moves with AI and machine learning in weather forecasting. You've got major initiatives like Mission Mausam and winds driving this.
Right. The potential is there for much better, faster predictions, especially for extreme events.
And we've looked at how this AI approach differs from the traditional physics-based NWP methods.
Highlighting the data-driven nature, the potential speed, but also the challenges.
Yeah, challenges like data quality, the complexity, that black box issue, needing more expertise and computing power, but also promising solutions, the hybrid models, crowdsourcing, expanding networks, collaboration, building skills.
And for you, particularly if you're preparing for the UPSC exams, understanding these tech advancements in a vital area like weather forecasting, drawing from sources like the Hindu Fae, this is really relevant stuff.
Absolutely. Think Maine's current affairs, even context for prelims, the impact on agriculture, disaster management, climate resilience. It's all interconnected and important.
Definitely syllabus territory.
So maybe a final thought to leave you with. As we rely more on these incredibly complex AI systems, how do we build and maintain public trust in them, especially when their inner workings can be a bit opaque?
That's a really important question going forward. How do we trust the black box?
Indeed. Something to ponder. If you found this discussion helpful for your UPSC prep or just for understanding a critical issue, please do hit like and subscribe to our channel.
Yeah, it helps us know what you find useful.
And definitely leave a comment. Any questions or other topics you'd like us to explore in a future deep dive, let us know.
We do read the comments.
And just a final reminder, the basis for our chat today was that detailed article in the Hindu. Thanks so much for joining us.